using origami to make a robot with softer hands than Rosie's. I'm Tonya Hall for ZDNet and Tech Republic, and joining me is Carl Vause. He's the CEO of Soft Robotics. Welcome, Carl.
Thank you so much, Tonya. It's a pleasure to be here.
What does Soft Robotics do?
So Soft Robotics, we're really a material science company that is disrupting and changing what robots can do. Traditionally, robotic technology has been seen in the automotive industry and electronics doing the same task over and over and over again. But as we move into different industries, manufacturing technology advances, we need robots that are more agile, can act more like humans, can work with various shapes and sizes. And so we take our patented material science technology and kind of give superpowers to robots. And through our gripping technology, we let robots, standard industrial robots that could be welding one day, now pick up the widest variety of items. So anything from fresh produce to chicken wings to shampoo to all the different things you see in the supermarket every day.
Define the problem facing legacy robots in manufacturing and how you're problem solving that, if you will.
Thanks, Tonya. That's a really important question. And so today the robotics industry is very large, but it's still dominated. Almost 70% of all robots sold today either go into automotive or electronics. So they're either making cars or phones. And the reason for that is they're very good at doing the same task over and over again with precision and repetition. Industries today that are constrained by labor and need automation to be successful aren't what we call structured environments. An automotive line is very highly structured. And so these unstructured things where we have variation in object size, shape, weight. So think about food packaging. Every apple is different. It's an infinite problem set. Or consumer goods, we have customers that have hundreds of different shapes, sizes, and weights of shampoo, from the 3-ounce travel size to the 64-ounce big box bottles. And so that variation is usually something that shut down robotics because they're back to doing that same task over and over again. With our technology, we now make those robots agile and adaptive so that they can come into these high mix, high variation environments.
How did this come about? How come we haven't had this technology already? Where did it begin?
So what's interesting is we've been working for decades. The robotics community has been working for decades to get to this agile, adaptable robotic system. And we've been using robotic technology to do it. Traditional rigid mechanisms, you think about like the Terminator hand, if you will. And what's interesting is our technology was actually invented by a chemist, not a roboticist, who knew material science. He knew how fluidics worked, and combining fluidics invented the field of what's now the academic field of soft robotics. And it's the ability to build robotics out of completely soft structures. And out of that research that was done by Professor Whitesides in the late 2000s, is we found out that these soft robotic, if you made a hand out of this, it was able to pick up the widest variety of objects without sensors and a lot of advanced technology. And so we said, what if we took that technology and paired it with traditional industrial robots? Do we solve this big problem that we've been working on for decades? And what we found is, yes, it absolutely solves this problem.
Tell us about robotics programming through Origami.
Robotics programming through Origami, that's one of my favorite phrases, by the way. And so we traditionally think about programming robotics through computer programming, computer engineers, doing a lot of sensor data, doing a lot of data analysis, figuring out how to move the robot. And what we do is we take layers of polymers, layers of rubbers and plastics, and by changing the way you put these layers together, you actually change the way the soft robot acts. And so do you want it to curve? Do you want it to grab? Do you want it to extend or elongate? So it really is just as you would cut out patterns in paper and then fold them to create something, is the way we put together the polymers to create soft robotic structures, very similar to origami. And so we program the material instead of programming the computer, if that makes sense.
Tell us about the evolution of Pickandplace. How have you progressed from programming for specific items to a general purpose hand?
Once again, great question, because in traditional robotics, if I wanted to pick up a different item, I had to know the weight of that item, the center of gravity of the item, how much force to apply to that item, and I had to program it. So now if you think about the number of bottles of shampoo or the different items in the supermarket, I had to know the exact weight, size, center of gravity for all of those and program it. And so it just was too expensive. It wasn't a problem that was solvable. With soft robotics, we don't need to know any of that information. We do what a human does. You see an object, you pick it up. So we tell the robot, go pick up what's there, and that's all it needs to know. And so now one of the things we do is we just run the robot, and we'll let anyone come and just put an item in front of the robot. The robot doesn't have to be taught. It doesn't have to know the object, and it will successfully pick that item up and move it. So when you think about manufacturing, what we're manufacturing today in the back to school season and what we're manufacturing in retail for the December holidays or graduation or beach time in July, they're very different objects. And so the ability to run your robots without having to do all this teaching and training, and know I can make, we do a lot of snack cakes. And so know I can make the zebra cakes this time of the year, and then make the Christmas trees in December, and then make the heart-shaped cakes in February without reprogramming my robot. It's really a fundamental breakthrough.
How do you scale an industrial robot up to agriculture or down for home use?
So agriculture was one where it was really about the ability to handle delicate objects. We do a lot with corn, we do a lot with tomatoes, we do a lot with lettuce, and it's really, the robots have been very good, and you need to be fast to package agriculture and do food processing. But the problem was being able to pick up a head of lettuce without destroying it. And with our technology, you can do that. And you can do it in a way that's cleanable and provides you wash down safety that you need in food. Now, getting it down to home use, that's something that when we think about the future is very exciting, because as we think about home robots, I always pick on Rosie the maid from the Jetsons. If you go back and you see Rosie, she had these horrible metal claws. And I can think of nothing worse to work around your house with than a robot with metal claws. And so with Soft Robotics, when we think about bringing it into mobile robotics and service robots, is we literally now have a robot that can pick up the things that you pick up every day in your house, whether it be a bottle of soda or plates or a cup or some food. And so we're really excited about taking this technology that's proven its adaptability and agility in industrial settings into these new emerging settings like harvesting or working in someone's home or elder care facility.
You know, how might you apply robotics to elder care? I think that's a very interesting application.
It really is. One of the things is we spend a lot of time learning about the elder care. And in the assisted living facilities, the most often time that a resident pages assistance is because they've dropped something. And more often than not, it's either a comb, a hairbrush, or the remote control. And so if you think about it, is now we have a scarce resource in caregivers. And with a soft robotic system we just demoed up, is we could have a mobile robot that could easily go in and retrieve things for the resident, whether it be a hairbrush, a comb, remote control, or something they've dropped. And so when we just think about that, that seems like a pretty simple application. You need the adaptability of soft robotics, but that's something that can really provide bandwidth and free up some of the resource constraints that we see in elder care today.
Carl Vause, CEO of Soft Robotics. I'm not going to look at Little Debbie's the same way again. I really appreciate your time. If somebody wants to connect with you, maybe they want to find out more about the work that you're doing, how can they do that?
Absolutely. Come to our website. It's www.softroboticsinc.com. There's a contact us form there. You can learn all about our products, our markets, our applications, and send a message directly to us if you'd like us to get in contact with you.
Sounds good. And if you guys want to connect with me, you can. You can find more of my interviews right here on ZDNet or Tech Republic, or maybe find me on the internet by going to tonyahall.net. I've got links to all my social sites. Thanks for watching.